So here we are at Chapter 2, Lesson 2A. Some of your things might just say Lesson 2 because there's a 2A and a 2B, but sometimes it just says 2 and 2B. So don't be confused by that, or try not to be. Today we're going to talk about factors and multiples. Again, something that you have dealt with in your past. And so we're just going to review it a little bit to help you out. Remember that factors are numbers that divide a number exactly, which means they are what you multiply together to get a number. So, for example, 5 times 2 are the factors of 10. When you multiply them, you get 10. And also, when you have a list of factors, the largest one that divides each given number is called the greatest common factor. So I'm going to show you what that looks like in the first example here. And this is called the set method of finding it. And typically I do it like a T-chart. So I'm going to show you both. But in example 1, we want to start listing all the factors of 12. So I just go through all of the numbers in order to see what will divide in if I can get 12. So I can multiply 1 times 12. And I'm going to put the 12 all the way down here. 1 times 12 to get 12. Is 2 times something 12? 2 divides into 12 6 times. Is 3 times something 12? 3 times 4 is 12. How about 5? Will 5 divide in? No, because it doesn't end in a 5 or a 0. 6. Oh, I already said 6 right here. As soon as you repeat a number that you already have used, you know that you've got all of the factors. So let's do 18. 1 times 18. Let's try 2. 2 times 9. Let's try 3. 3 times 6. Really helps to know your multiplication facts. 4. 4 times 4 is 16, but not 18. 5 doesn't end in a 5 or a 0. 6. Oh, look, I said 6 already. So I know that I'm done listing all of my factors and I have them all. So now let's find our common factors. They both have a 1 in common. They have a 2 in common. They have a 3 in common. They have a 6 in common. So they have 1, 2, 3, 6, and the greatest of those all is 6. So that's what a greatest common factor is. All right, so we do have another method to determine that called the ladder method. I'm going to show you that quickly, but I'm also going to talk about using the T-chart that you're probably really familiar with, which is just like this listing, but more vertically. So I'm going to do 12 and 18 again so that you can see I'm still going to get 6. I look for a number that divides into 12 and 18. Any number that will divide into 12 and 18. So I'm going to go with 2 because they're both even. 2 divides into 12, 6. And 2 divides into 18, 9. So it's kind of like upside down division. All right. Now, 6 and 9 share another factor in common, 3. 3 divides into 6, 2, and 3 divides into 9, 3. Because these are in a row, I know that I'm done. And my GCF, I like to draw a big G around them, are those numbers on the side multiplied together. 2 times 3 equals 6. And that is the same thing we got up here. Okay. The T-chart just looks like this. We take 12 and we list our factors this way. 1 times 12, 2 times 6, 3 times 4. And when I go to check 4, it's already there. So that's how I know I'm done. Okay. And then 18, 1 times 18, 2 times 9, 3 times 6, 4 doesn't work, 5 doesn't work, and I said 6 again. So this way you again can see what you have in common. You've got 1, 2, 3, 6, and 6 is the greatest. All right. So that's the 3 different methods that we talk about. And this one right here, which is basically the same as this one, you're going to use in your future. So if you want to use the ladder because it's a nice little trick, you can, but you don't have to. All right. Example 2 is 3 and 17. What are the factors of 3? The only thing I can think of is 1 times 3. 2 won't go in, and 3 is already there. How about 17? 1 times 17. 2 won't work. It's not even. 3 won't work because 7 plus 1 is 8. 3 doesn't go into that. 4 times 4 is 16. 5, it doesn't end in a 5 or 0. 6, I could keep going, but this isn't going to work. These 2 numbers are both prime numbers. And when there's no common prime that goes into all of them except for 1, then the GCF is 1. We call those numbers relatively prime. So why is it important to even know the GCF, the greatest common factor? Well, the biggest reason is in reducing fractions, where we divide both the numerator and the denominator by the GCF. So we already found the GCF of 12 and 18 twice, maybe 3 times already. So we're going to divide this by 6, 6. And I got the 6 from previous page. I got it from here. And I got it from here. Okay, because we did 12 and 18 2 or 3 times. And again, we can divide by 6, 6 because 6, 6 is the same as 1. And when you divide by 1, you get your same number. So it's okay to do that. It just simplifies it to make it in as simple terms as you can. So 12 divided by 6 is 2, and 18 divided by 6 is 3. 27 and 36. Did we find that one? We did not. So I'm going to come off to the side and make some T-charts. 27, 1 times 27. 2 won't work because it's not even. 3 times 9 is 27. 4 doesn't work. 4 times 6 is 24, and 4 times 7 is 28. 5, it doesn't end in a 5 or 0. 6 times 4 is 24. 6 times 5 is 30, so that doesn't work. 7, nope. 8, nope. 9, 9's already up there. So there's only 4 factors, even though that number is a little larger. Okay, 1 times 36. 36 is even, so 2 will go into it. So if you need to make a little division box up here, 2 divides into 3 once, and 2 divides into 16 8 times. So this is 2 times 18. 3 times 12, and I know that because 3 goes into 3 once, and 3 goes into 6 twice. 4, if you know your multiplication facts real good, 4 times 9 is 36. 5 doesn't work. 6 times 6. And because I've repeated that number, I know I'm done and I've included everything. So what do they have in common? They both have a 9 is their greatest common factor. So I'm going to divide this by 9 ninths. Again, that has a value of 1, so I can divide by it. 27 divided by 9 is 3. And 36 divided by 9 is 4. If you don't know your multiplication facts, I really recommend going through, finding an app or something online, or getting some flashcards. They have them at the dollar store, or making some flashcards to really help you memorize those. It would be really important to you. So we have our factors of 36 here. So I'm just going to do 24 and see what they have that matches. 1 times 24, it is even. 2 times 12. 3 times 8, again, if you know your facts, that's simple. 4 times 6, 5 doesn't work, and there's my 6 again. So I know that I have everything. So let's see what they have in common. They have 1, 2, 3, 4. They do both have a 6, Anything bigger? Oh, they both have a 12. Look at that. They both have a 12. So I'm going to divide this by 12 twelfths. Again, because 12 twelfths has a value of 1. 24 divided by 12 is 2. You can use your chart to help you here, right? And 36 divided by 12, 36 divided by 12 is 3. So once you've made the charts, they're really handy and helpful. Let's go to the least common multiple. Okay, least. Now we're talking about multiples. When I see the word multiple, I think multiply. So instead of finding what it is that I put together to get the number, I'm going to start with a number and multiply them. So instead of making a T-chart, I'm going to have kind of a long list. So for example, let's start with 10. 10 times 1 is 10. 10 times 2 is 20. 10 times 3 is 30. You go right in a row. 10 times 4, 10 times 5, 10 times 6, 10 times 7. I'm not sure where to stop, right? Because I'm just starting the problem. So you'll start to get good at this and you'll know when to stop. Now, again, you have to know your multiplication facts really good. Starting at 8 to list the multiples. What I'm listing here are multiples. 8 times 1 is 8. 8 times 2 is 16. I'm checking down here to see if anything matches. 8 times 3 is 24. 8 times 4 is 32. 8 times 5 is 40. That makes me stop and think because that ends in a 0, and I know all of those end in zeros. So in this case, the smallest, the least multiple that they have in common, that they share, is 40. So we just have to list them all out. It gets a little tricky when you have 3 because I need 3 rows, okay? So 3 times 1, 3 times 2, 3 times 3, 3 times 4, 3 times 5, 3 times 6, 3 times 7, 3 times 8, 3 times 9, 3 times 10. Now, I don't know how far I have to go, but I'm going to try. All right, 6 times 1 is 6. Oh, they both have a 6. That'd be cool. But 8 times 1 is 8, so that one's not going to work. 6 times 2 is 12. Oh, they both have a 12 here. What's 8 times 2? 16. No, that one's not going to work. 6 times 3. 6 times 3 is 18. Oh, they both have an 18. 3 and 6 have a lot in common. 8 times 3 is 24. Well, here's a 24 and here's a 24. Let's do the middle one again. 6 times 1, 6 times 2, 6 times 3, 6 times 4 is 24. So they each have a 24, and that's the first number I get to that they all have. So it is the least common multiple of 3, 6, and 8 is 24. Let's do 4, 5, and 15. 5 and 15 would be kind of easy if it's the only one we had to do, right? Because it would be 15. So 15, 30, 45. Let's do 4 times 1, 4 times 2, 4 times 3, 4 times 4, 4 times 5, 4 times 6, 4 times 7, 4 times 8, 4 times 9, 4 times 10. 4 times 10 is 40. I can get 5 to a 40. 15 is 45. Ugh, that's yucky. All right, let's keep going. I'm going to make it and go again. 4 times 10. 4 times 11. 4 times 12. Ugh, this is getting yicky. Oh, this is where I'm going to show you my little trick. I don't know if Mrs. Ranke will like this or not. 4, 5, and 15. So once I start thinking, man, I don't know what to do, I'm going to look to see if I can divide into anything with my ladder that I showed you earlier. Well, nothing goes into all 3, but 5 will go into 2 of them. 5 divides into 5 once, and 5 divides into 15 3 times. Since it does not divide into 4, we just bring it down. How about this row here? Can I think of anything that divides into any of that? No. So what I do is I multiply everything on the outside together. 5 times 4 is 20. 20 times 1 is 20. And 20 times 3 is 60. So I would have had to keep doing these until I got to 60. So I'm glad I knew that little trick to help me out. Sometimes I use that little trick. So it's good to have in your pocket of math tools. I think this is the end. Yeah, that's exciting. So 7 and 11. Sometimes the LCM is just the product of two numbers. So if you think about 7 and 11, they're both prime. Their GCF, their greatest common factor they share would be 1. And I could list them all out, and I won't get one that's the same until I get to 77. So sometimes when you just have to multiply them together to get their LCM. And you could list them out: 7 times 1, 7 times 2, 7 times 3, 7 times 4, 7 times 5. You will get to 77 eventually. And I think when you started writing the 11s, you're going to be like, none of these are going to be 7s until I get to this one. So that's another way to figure that out.